You're touching something right now. Your fingers on your phone, your back against a chair, your feet on the floor. You've been told this your entire life. You believe it completely. It feels so obvious that questioning it seems absurd. But here's the problem. You've never touched anything. Not once. Not ever. And you never will. Think about that. Let's start with something simple. Pick up an object. Anything. A pen, a cup, your phone. You feel its weight, its texture, the coolness or warmth of its surface. You feel resistance when you press against it. You can tap it, flick it, set it down, pick it back up. Every sense you have tells you the same story. Your hand is making contact with this object. Skin meeting surface. Matter touching matter. This is not controversial. This is not complicated. A child understands this. But that confidence, that certainty, that's exactly the problem. When you press your finger against a table, something stops you from going through. You feel that resistance, that hardness, that solidity. Your brain interprets this as contact, as touch. And for thousands of years, that interpretation seemed perfectly reasonable. Solid things stop other solid things because they're touching. Matter meets matter. What could be simpler? Philosophers debated consciousness and existence and the nature of reality itself, but nobody questioned this. The ground beneath their feet was solid. The chairs they sat in were solid. Their own bodies were solid. Touch was the one thing that made sense. Then scientists started looking closer. Not with their eyes. Eyes can't see what matters here. They started probing matter itself, breaking it down, asking what things are actually made of. And they found something quiet at first, easy to dismiss, but it wouldn't go away. When you break matter apart, you find atoms. Everyone knows this now. But pause for a moment and really think about what an atom is. It's a nucleus in the center. Protons and neutrons packed together, and then electrons, orbiting at a distance. And between the nucleus and the electrons? Nothing. Empty space. Not mostly empty space. Not a lot of empty space. If an atom were the size of a football stadium, the nucleus would be a marble at the center. The electrons would be specks of dust orbiting at the outer walls. Everything in between? Absolutely nothing. Now scale that back up. Your hand is made of atoms. Trillions of them. The table is made of atoms. Trillions of them. And each atom is almost entirely empty space. So when you press your hand against the table, what you're really doing is bringing two clouds of mostly nothing toward each other. This should bother you. Because if atoms are almost entirely empty, and everything is made of atoms, then everything is almost entirely empty, including you. But here's where it gets strange. If atoms are mostly empty space, why doesn't your hand pass through the table? Why do solid things feel solid? What's actually stopping you? This is the question most people never ask. They learn about atoms in school, nod along, and never connect it to the feeling of touching something. But once you ask it, you can't unask it. Scientists in the early 20th century knew about atoms. They knew about electrons. They knew about empty space. But they also knew that something was pushing back when objects met. There had to be a force, an interaction. And that's when they started measuring. They took charged particles and fired them at other charged particles. They watched how they moved, how they deflected, how they repelled each other, and they found something remarkable. The particles never actually touched. They got close, very close. But at a certain distance, they began pushing against each other, repelling. with a force that increased the closer they got. This wasn't a theory anymore. This was measurement. There was no going back. The force they were seeing was electromagnetism. Electrons carry a negative charge. When two electrons get close, they repel each other. Not because they're bouncing off each other like billiard balls, but because their electromagnetic fields interact. Think of it like two magnets with the same poles facing each other. You can feel them pushing apart before they ever make contact. But here's the critical part. They never make contact. The closer you push, the harder they resist. But no matter how hard you push, they never actually touch. There's always a gap. Always. Now apply that to your hand and the table. The atoms in your hand are mostly empty space, with electrons orbiting the nucleus. The atoms in the table are mostly empty space, with electrons orbiting the nucleus. When you press down, the electrons in your hand get close to the electrons in the table, and they repel. The electromagnetic force pushes back, harder and harder as you press harder and harder. That resistance you feel? That's not contact. That's repulsion. You're not touching the table. You're being repelled by it. This is where your brain should start feeling uncomfortable. Because every experience you've ever had tells you that you're touching things, but the physics tells you something else. You've never touched your phone. You've never touched another person. You've never touched the ground. The atoms that make up your feet have never made contact with the atoms that make up the floor. There's always a gap. A tiny, infinitesimal gap, but a gap nonetheless. Let me say this again, slowly. When you shake someone's hand, the electrons in your skin repel the electrons in their skin. When you sit in a chair, the electrons in your body repel the electrons in the chair. When you walk, you're not touching the ground. You're hovering above it, suspended by electromagnetic repulsion between the atoms in your feet and the atoms in the earth. Every step you've ever taken, every object you've ever held, every hug you've ever given, none of it was contact. All of it was repulsion. This should break your brain. Not because it's complicated. It's not. But because it contradicts something so fundamental to your experience that accepting it requires rebuilding your entire understanding of physical reality. You don't live in a world of solid objects touching each other. You live in a world of electromagnetic fields pushing against each other, creating the illusion of solidity. Now here's the part most people miss. Why can't you just push harder? If there's a gap, why can't you close it? If it's just electromagnetic repulsion, why can't you overcome it? This is where the universe reveals something even stranger. As you push atoms closer together, the electromagnetic repulsion increases, not linearly, exponentially. The force grows so rapidly that reaching the point where atomic nuclei actually make contact requires an absurd amount of energy. You can't do it by pressing down on a table. You can't do it by jumping off a building. You can't do it by crashing cars together. To force atomic nuclei into contact, you need the conditions inside a star. Millions of degrees, crushing gravitational pressure. That's nuclear fusion. And even then, it only works because the strong nuclear force, another fundamental force entirely, overcomes the electromagnetic repulsion at extremely short ranges. So there's a wall, a hard limit. The universe won't let you touch. Not because you're not trying hard enough, not because you don't have the right technology, but because the structure of reality itself prevents it. Electromagnetic repulsion is not negotiable. It's not a suggestion. It's a law. But here's what makes this truly unsettling. This isn't just about atoms. It's about perception. Everything you think of as feeling, something is actually your nervous system interpreting electromagnetic repulsion. When you touch a hot stove, you're not feeling heat transferring through contact. You're feeling the electromagnetic interactions between atoms vibrating rapidly in the stove and the atoms in your skin. When you feel pain, you're feeling electromagnetic fields triggering nerve signals. When you feel pleasure, same thing. Every sensation you've ever experienced is your brain's interpretation of forces that never involve actual contact. Think about what that means. You've never truly felt anything. Not in the way you think. The texture of fabric, the warmth of another person, the coldness of ice. All of it is electromagnetic interaction translated by your brain into something comprehensible. Your entire sensory experience of reality is a user interface, a translation layer between the quantum weirdness of atomic interactions and the macroscopic world your consciousness inhabits. And this applies to everything. Right now, you're not sitting in a chair. You're floating above it, suspended by electromagnetic forces so perfectly balanced that your brain interprets it as solid support. You're not standing on the ground. You're hovering, held up by repulsion between quadrillions of atoms. Every object you see as solid is mostly empty space, held together by forces that never allow true contact. You live in a ghost world, a universe of fields and forces and interactions that create the convincing illusion of matter. But here's the strange beauty of it. This isn't a flaw in reality. This is how reality works. The solidity you experience isn't real in the way you thought, but the forces creating that experience are absolutely real. Electromagnetism is real. The quantum mechanics governing atomic behavior is real. The illusion of touch is constructed from something deeper and more fundamental than touch itself. And we know this is true because we've tested it. Every prediction quantum electrodynamics makes about how charged particles interact has been confirmed to absurd precision. We've measured the strength of electromagnetic forces. We've observed atoms repelling each other. We've built entire technologies, computer chips, MRI machines, particle accelerators, based on the fact that nothing truly touches. This is not philosophy. This is measured reality. Richard Feynman understood this better than almost anyone. He spent his life explaining quantum electrodynamics, the physics of how light and matter interact. And he was obsessed with this question of contact. He once said something like this: when you sit in a chair, you're being held up by the electromagnetic force, the same force holding atoms together, the same force responsible for all of chemistry, all of biology, all of structure in the universe. You've never sat on anything. You've been repelled by everything you've ever tried to touch. And that repulsion, that's not separate from you. It's what you are. The atoms in your body are held together by electromagnetic forces. The shape of your hand, the beating of your heart, the firing of neurons in your brain. All of it depends on electrons repelling and attracting in precise, quantum mechanical ways. You are a standing wave of electromagnetic interactions, a pattern of forces, a structure with no solid foundation. So when you reach out to touch something, what's really happening? Two patterns of electromagnetic forces are interacting. Neither is solid, neither makes contact. But the interaction is real. The repulsion is real. And your brain translates that into the sensation of touch. Think about the implications. Every handshake you've ever given was two electromagnetic fields pushing against each other. Every kiss was atoms repelling atoms. Every embrace was a dance of forces that never closed the gap. You've been alone, in a sense, your entire life, suspended in space, never truly connecting with anything outside yourself. But you've also never been separate, because those electromagnetic fields don't have sharp boundaries. They extend outward, diminishing with distance, but never truly ending. Every atom in your body is interacting, however faintly, with every other atom in the universe. You're not isolated. You're entangled in a web of forces that connects everything to everything else. And here's the final quiet truth. This isn't a rule someone invented. This is how reality is built. The universe doesn't care if this makes sense to you. It doesn't care if it feels wrong. It doesn't care if you find it unsettling. This is what it is. And the strange thing? We only know this because scientists believed in other laws so deeply that they followed them into territory that made no sense. They trusted electromagnetism enough to measure it precisely. They trusted quantum mechanics enough to predict atomic behavior. And when those laws said nothing touches, they accepted it, even though it contradicted everything their own senses told them. That's the pattern in physics. One trusted law reveals another hidden truth. That hidden truth reveals another, and another, until you're standing in a universe that looks nothing like the one you started with. But every step was inevitable. Every conclusion was forced by the evidence. You can't unknow this. You can't go back to thinking of touch as contact. Every time you pick something up, you'll remember. Every time you shake someone's hand, you'll feel it. Not touch. Repulsion. The universe pushing you away from everything you try to reach. And maybe that should be terrifying. Maybe it should make you feel small and alone, and adrift in a reality that refuses to let you connect with anything. But maybe it should make you feel something else. Awe. Because the fact that we can know this, that our minds can grasp something so counterintuitive, so alien to our experience, is astonishing. We are patterns of forces trying to understand the forces that make us. And somehow, we're succeeding. The universe is not obligated to make sense to us. The miracle is that it ever does. And the deeper miracle is this. Even when it stops making sense, even when it reveals that nothing we thought was solid actually is, we keep looking. We keep measuring. We keep asking. You've never touched anything. You never will. But you know that now. And knowing it changes everything.